So I think direct substitution is going to work very well for us because we're used to doing that in our math studies where we plug in a number and see what we get out. But that's not to say that direct substitution might not lead to, we'll say, some headaches. So what if we try to do direct substitution and something doesn't exactly make sense or go well for us? So let's try these ones. If we were to directly substitute in -3, we would have 9 minus 12 plus 3. Notice how that would result in 0. If we try to do that in the denominator, we'd have 9 minus 6 minus 3, and that would also result in 0. So we tried direct substitution. That should always be our first try or our first bet to see what would happen for these limits. But notice how this is not exactly a result like we got on the previous page. Okay, I briefly discussed this before. 0 over 0 is referred to an indeterminate form. Indeterminate is basically telling us that the limit exists. We just need to do a little bit more to figure it out. Okay, so the limit might exist. Okay, we can't rule it out just yet, but we have to do a little bit more to actually see what the value might be. So this 0 over 0 is also signifying that we have a hole at the x value of -3, because notice how it makes the top 0 and the bottom 0, so that factor would be eliminated or cancel out. So indeterminate form means a limit possibly exists, but it's also signifying that we have a hole at that spot. Let's try the same equation, but this time we're going to directly substitute in a different number. We're going to try to plug in 1. So we would have 1 plus 4 plus 3, which would be 8. And if we try to plug in 1 down below, we'll have 1 plus 2 minus 3, which would be 0. Now, notice how on this one we have the same equation, and we would still be plugging in 1. Okay, the plus or minus doesn't mean anything just yet. So we would get the same result. Now, instead of getting 0 over 0, notice how we get a number over 0. This is signifying that the value you are approaching only shows up as a factor in the denominator and not the numerator. So whenever we get a number over 0, that's signifying that we have a vertical asymptote at that specific x value that you were approaching. So since we have a vertical asymptote, the limit never exists at a vertical asymptote, because notice how you're going down and up drastically. The left and the right side never match. So the limit never exists at a vertical asymptote. Okay, now we can kind of confirm that with the graph here. So this is the same exact graph of the function that we were looking at the top. Notice how if we practice graphically, if we approach -3 from the left and the right, we'd be approaching that hole that we analytically proved was there, and the height of that hole happens to be a half. If we approach 1 from the left, we're going to go down forever. And if we approach 1 from the right, we would be going up forever. Okay, signifying that vertical asymptote. So I know we're really familiar with holes and asymptotes. We did a lot of these in pre-calculus. So I wrote down some of the things that we did to help us figure out when is there a hole and when is there an asymptote. We're going to factor the top and bottom. And hopefully we already know that the factors that cancel result in holes, and the factors that don't cancel result in those vertical asymptotes. So we're going to try to prove that again using this equation. Okay, the same one as the graph given at the top of the page. So if we actually tried to factor the top, two numbers that multiply to 3 add to 4, would be 3 and 1. And then on the bottom, two numbers that multiply to -3 but add to 2 would be +3 and -1. So notice how the x plus 3 factors would cancel. So that is our hole at x equals -3. The x minus 1 factor did not cancel, so we have a vertical asymptote at the x value of 1. Now what's interesting about this is notice how we're left over with x plus 1 over x minus 1. what we can do is use this simplification to actually help us calculate the height of the hole. So if we determined that the hole is at -3, let's go ahead and substitute in -3 in for those x's. Remember that -3 was the x value that we were approaching anyway. So even though -3 might not work initially because we got 0 over 0 like we did at the very top, notice how we can rewrite the equation by factoring, and we can simplify the way that fraction looks. So if -3 doesn't work initially, let's rewrite it so that it eventually does. If we try to plug in -3, we'll get -2 over -4, which would simplify to a half. And notice how that was the height of our hole found in the graph previously. So this limit value would be a half that we're approaching from the left and the right.